All right, so I'm going to work through some of the questions from the STAAR Prep Day 5 exit ticket. These are dealing with some of our systems of equations. So let's start looking at that first question right over there. Two customers going to the post office to buy postcards in large envelopes. Each postcard contains the same amount, and each large envelope costs the same amount. So the postcards and the envelopes cost the same amount. We don't know how much they cost, but the information that we got, the first customer paid $12 for 14 postcards, and it's a different color for the second 5 large envelopes. 12 postcards and 5 large envelopes. The other customer paid. I'm gonna make that a little bit different because three parts of information right over here. We have 2480 right over there, and then we have 10 postcards and 5 large envelopes. Sorry, 15 large envelopes for the second customer. And we're trying to find the cost in dollars of each large envelope. So the classic setup for these systems of equations is this right over here. We're going to say, for that first customer, we have postcards, we have large envelopes. For this first problem, I'm going to make X the postcards and Y the large envelopes. We're going to need to set up a system of envelopes. We're going to set up a system of equation to solve for X and Y. And systems of equation is two equations happening at the same time. So we need two equations created from each customer. So the first customer has bought 14 postcards. 14 postcards. We don't know how much each one are. So X is the cost of the postcards, and Y is the cost of the envelopes. So be a little bit more specific right there. If we have 14 postcards, we don't know how much they cost, but we do know when we add it to the cost of the 5 large envelopes, it gives us a total of $12. That is customer number 1. Customer number 2, move this information over here to the side. Customer number 2, $10 postcards. I made X my postcard, so I'm going to make it 10 postcards plus the large envelopes, 15 large envelopes, for a grand total of 24.80. 24.80. Now, ideally, we can put both of these equations into Desmos to solve it out. However, if we're in test mode, if I try to type this in, 14x plus 5y equals 12. On the STAAR test, it's not going to graph it. We need to put y by itself. Same thing with the other equation. So since x and y, here they are. Here's my x, here's my y. Since x and y are in the same side of the equal sign on both equations, because remember, we've got two equations here, that means we're going to have two lines eventually, I'm going to need to move things over on both of these. So let me move the second equation over to the side. Be a little bit more. There we go. There we go. And let's take a look at this first equation. Move it back over so we can see that. And that first equation is 14x plus 5y equals 12. If I have my x's and y's on the same side like this, x's and y's are on the same side like that, remember, two parts we got to do to get the x by itself. Move the x over and divide by the y. So the x part moves completely over. When we move it over, we have to change the sign. Get rid of these marks right there. So we move the x over 14x goes to the other side of the equal sign. Actually, I'll just write it out. I'll do it in this color right over here. So 14x is going to go to the other side of the equal sign. 5y stays where it is, equals 12 minus 14x. And then the second equation over 5. We have to divide the number in front of the y. So that first equation I can graph into Desmos. Y equals, put the divide sign so we can put the top part, 12 minus 14x over 5 gives me my first line. I have to do the same thing with the other equation. Some of these questions may take you a minute, but these are the steps you're going to have to do. Again, we move the x over to the other side of the equal sign. This time we're moving it to the second equation. So 24.80 minus 10x. To get the y by itself, we need to divide that 15 away from the y. So the number in front of the y, we divide that out. And that will give you what we would do for the second equation. So we type that in. Y equals, again, 24.80 minus 10x over 15. And I'm going to see where these two lines cross. They cross right over there at 0.35 and 1.42. Again, x's and y's. I made x the postcard cost and y the large envelope cost. That means the cost of each postcard is 35 cents. The cost of each large envelope is $1.42. And in this question, what are we looking for? The cost of each large envelope, making the answer A. The trick for this question, you have to move things over in Desmos in order for us to graph it. Let's try number 2, and this is just a setup here. So we don't have to worry about solving it. Here we're just going to set it up. 15 plates in a kitchen cabinet. The diameter of each plate is either 7 inches or 12 inches. Let me zoom it out so we can read the whole thing. The diameter of all the plates combined is 140 inches. Putting a little bit of geometry in here, but we can still think of this as an algebra system of equation situation because we have two sets of information about the plates. We know there are 15 plates in the kitchen. So we know there's 15 plates in the kitchen cabinet. The diameter of each plate is either 7 inches or 12 inches. So we have two types of plates, 7-inch plates and 12-inch plates. And down here on the second line, it tells me that we are going to use X for the 7-inch plates and Y for the 12-inch plates. If they tell you in the question, what's your X and what's your Y, we're going to use that. So X, 7-inch plates, and Y, 12-inch plates. We know there's a total of 15 plates. So that means if I take the number of 7-inch plates, the X, I'll write that a little bit better, X, and the number of 12-inch plates, Y, small plates plus the big plates, equals a grand total of 15 plates. Now we have to consider the fact that the diameter of all the plates combined is 140. That means when we lay them all out, that gives us a total of 140. So 7-inch plates for the diameter for the 7 inches, so that's X. So that means 7X plus the 12 inches for the Y plates, 12Y. Put them all together, we get 140. We get 140. Give me a minute to reset this. It gives us 140. And I'm just setting up the question. I'm just setting up the equation. Which equation has, which answer choice, excuse me, has both these two equations? That's the setup. A has x plus y is 140. That's wrong, so that's out. B, 7x plus 12 is 140. No. X plus y is 15. 12x and 7y is 140. The only problem is x is the 7-inch plates, not the 12-inch plates. C becomes the answer. Again, we're just setting things up, and then we're just solving it out. All right. I'm going to do about 4 more of these. Move these up. Number 3. A bus travels 2 different routes, a green route and a blue route. The routes are different lengths. We do know that on Monday, the bus travels the green route 6 times and the blue route 5 times for a total of 52 miles. On Tuesday, the bus travels the green route 12 times and the blue route 13 times, going 119 miles. We're looking for the length of the green route only. So this is a setup, again, like the very first question. I have to set up the system of equation, and then we have to solve it. All right, so let's go ahead and set this up. We need the green route and the blue route. I'm going to go ahead. Just going to do it this time by highlighting it. Going to make the green route the x. I'm going to make the blue route the y. Another system of equation. Excuse me. So x is going to be the length of the green route. Y is going to be the length of the blue route. If you travel that green route 6 times for x miles, and you travel the blue route 5 times, each time with y miles, you total a grand total of 52 miles. Same thing on Tuesday. So this is on Monday. And on Tuesday, you took the green route 12 times for x miles, add that to the blue 13 times for the blue route for y miles, going a grand total of 119 miles. Again, they're in standard form, so I can't place these into decimals like this. I have to move the x and the y's over. So I'm going to do that. 6x goes to the other side of the equal sign. 52 minus 6x. Divide that by the number in front of the y, which is 5. So for the green route, I should have done this. I should have done that in green, but so this is the green route. I'll just write it. So this is the green route. 52 minus 6x over 5. Type that into Desmos. 52 minus 6x. Put that over 5. Gives me the first line right over here. I know it's graphed because I see that purple line right there. Might have to zoom it out to see it, and there it is. Now I'm gonna do the blue route, which I'll do ironically in red. We're just here for the numbers, right? Thankfully, so we don't have to worry about the colors. So we move the 12x to the other side. 119 minus 12x. 12x goes to the other side, divided by the number in front of the y, which is 13. And then we type that into Desmos. Y equals 119 minus 12x divided by 13. Here, and there we go. Where do the two lines cross? 4.5 and 5. We're looking for the length of the green route. Green route is the x number. So we're looking for the x answer here, 4.5 Your answer, 4.5. Number 4. Uh-oh. It's a fill in the blank. Let's take a look at what we have right over here. A manager purchased a total of 21 coffee mugs and keychains. Each mug is $8.50. Each keychain is $2.75. If the manager spent a total of $132.50, how many coffee mugs did the manager purchase? Okay, so let's figure this out. We have coffee mugs and keychains. We know, and we have a total of 21 coffee mugs and keychains. So they added them together. Looks like we're setting up another one. So I'm going to make X the coffee mugs. I'm going to make Y the keychains. And if I add them together, X plus Y equals 21. Zoom it in a little bit right over here. Each coffee mug is $8.50. So X is the number of coffee mugs. Y is the number of keychains. Right over here. X is the number of coffee mugs. Y is the number of keychains. Then we're just going to take a look at the costs now. Each mug is $8.50. So write that down. 8.50 for every coffee mug, every X. Plus, each keychain is, how much is that? Come on, bring it back. Okay, there we go. $2.75 for every keychain. So $8.50 for every coffee mug and $2.50 for every keychain. Make sure I'm able to scroll around on this. There we go. Sorry, $2.75. $2.75. There we go. $2.75. Make sure you're able to go back and verify your numbers. Otherwise, if you misremember a number or two, you're going to get your question wrong. Very important to verify all of your numbers here. Going to move this information off to the side. Just like that. Now all I'm going to do is place that into Desmos, but I can't because I got X and Y on the same side. Thankfully, with this first equation, I could just move the X over just to give me 21 minus X. And the Y is already by itself. So that makes things a little bit easier on that end. Y equals 21 minus X. And then the second one, a little bit more complex because we got more numbers with this. But the 850X goes over 8.50X divided by the number in front of the Y, which is 2.75, which we will type in right over here. Y equals, put the divide sign over here, 132.50 minus 8.50X over 2.75 for the number in front of the Y. And if we zoom out in Desmos, my Desmos is stuck. Up there we go. I have 13 and 8. 13 is the X, 8 is the Y. That means I have 13 X's and 8 Y's. 13 coffee mugs and 8 keychains. What am I looking for here? How many coffee mugs did we purchase? 13. And if you add it together, 13 plus 8, 21. All right. So what's the solution to this systems of equation? I do not have y equals right over here, but I do have y equals right over there. Makes it a lot easier on that end, so all I have to do is just make sure they're both Desmos ready. That second one's already good. We just have to fix that first one. So I'm actually going to start with that second one. Y equals, put the divide sign on top, so we got negative 13x plus 92 over 2. There's the first one. Now for that second equation, 10x minus y equals 53. Again, move the x over to get the y by itself. Just move the x over. That'll change its sign. And we got negative y, which won't graph. I don't think negative y will graph. Will it? Equals, no, it will not. 53 minus 10x. No, y has to be by itself, even if there's a negative in front of that. How are we going to get rid of that negative? We divide the number in front of the y. If there's no number in front of the y, we'll call it a negative 1. We'll put a 1 right there, and if it's a negative y, we'll call it a negative 1. So the negative y, we'll divide this right over here. I'm going to rewrite this way. Divided by negative 1. Here's that. And the solution to the system of equation is where the two lines cross. And the two lines cross at 6 and 7, making the answer A.